Another important things, you calculate the resonant frequency omega r and the peak value MR in the second order system. This is very important. In the second order system, as you find the change s to the j omega, you find the magnitude of the system is the real and the imaginary square. Since this is going to become maximum value, this should be the minimum value. If I put the name of the denominator GW is omega n2 minus omega squared power 2 plus 2 sigma omega power 2, then this will be minimum. That means if I take the derivative of the j prime omega equal to the 0, I can find the minimum value of this system. If I take the derivative of the denominator based on the omega, you will find this equation. If this equation is equal to the 0, you find the omega r or resonant frequency equal to the 0 and the omega r equal to plus minus omega n root of the 1 minus 2 sigma 2. Since omega is bigger than 0, omega resonance is a positive value of this root. Omega n root minus 1 minus 2 sigma 2. If this one is equal to 0, you will find the 1 minus 2 sigma 2 equal to the 0. 1 minus 2 sigma 2 equal to the 0. You find the sigma is equal to 1 root of the 2, or sigma equal to root of the radical 2 divided by 2 equal to 0.7. Here this calculation. For the resonance only exists for sigma less than this, because if the less than this, resonance will be happen, and the omega r should be less than omega n. Okay, we find the omega, the magnitude of the resonance will be absolute value of this. We calculate 1 2 sigma root of the 1 minus sigma 2. If sigma go to the 0, this value 1 divided by 0 go to infinity. That means the magnitude go to infinity. In this case, if the input has a frequency of omega resonance, the output of my system become MI, omega resonance sinus omega RT plus phi omega. That means if sigma become very small, omega, the frequency of system become the same as the frequency omega resonance, and the wire output will be go to infinity and will be catastrophe will be happen, because my system completely will be unstable. This bridge is calculation wrongly, and they become mechanical resonance and the collapse of the Brockton suspension bridge and the Anger bridge. Or another one is the Tacoma narrow bridge. There's a resonance, that means omega become exactly omega resonance, and the sigma they calculate is very small, and the omega, that means the output will go to infinity and damage the bridge. For calculation about the omega r is very easily. You can find the magnitude of the resonance that we saw 1 2 sigma root of the 1 minus sigma 2, and if you multiply together, you can easily calculate about the sigma based on the omega r. If you make the x equal to sigma 2 minus x will be plus 1 for the magnitude of the resonance square is equal to the 0, and you can find the delta. Then take the integration of here, sigma equal radical x, and the sigma should be less than 0.07. And if you see, you can easily, we saw the magnitude of the second order system. Here will be the resonance, or the magnitude of the resonance will be happen. And this is the bandwidth of the resonance. Bandwidth of the resonance will start from the beginning until this point. The calculation about the bandwidth and the frequency of resonance is easily can calculate. Omega bandwidth become omega n, and the root of this synthesis T settling time will be 4 sigma omega n, and the T peak will be pi omega d. For the calculation about the omega bandwidth, I will not ask you to memorize this. I will give you the formula. I will ask you to calculate about the omega bandwidth, and for the T settling time and the T peak, easily you can find the answer. But in this course, we saw the different frequency. Omega n, if you remember, is a natural frequency. Omega d is omega n root of the 1 minus sigma 2 is a damped frequency. Omega r, the name is a resonance frequency. The formula will be the same as omega d, only sigma have a 2 sigma omega n and omega bandwidth. Here they ask you to plot the Bode diagram of the second order system. Easily you can find the magnitude and the phase based on the different omega. You can plot the 6. I can pass this. You can I will give you this. Here they give you the Bode plug of the G defined by this, and I will let you to solve this exercise together. If you have any question, you can ask me, and it's not difficult. Just only you can substitute the S by the J omega. With the different omega, you can find the different phase and different angular, and or the different phase and different magnitude. Just only careful about the magnitude base should be based on the decibel, will be 20 logarithm of the magnitude, and phase will be arctangent nominator minus arctangent dominator.